Hi there and welcome back to Triplicate and back onto the super battery charger come tester, and I really want to crack on and get this thing working, and then we can have some fun investigating how rechargeable batteries behave. So to that end, this video is probably going to be a bit bitty. I'm just going to say I've done this, I've done that, and that works, and here it is, and on we go to the next. So I guess firstly a bit of housekeeping. There is a video I did on Arduino Create, the Arduino web editor, and my problems with it, and I finally gave up on it and installed the IDE that runs locally on your computer, and here it is. There we go, and it all seems to work fine and compiles and uploads quickly and reliably. The only thing I've found wrong with it is since my eyesight is somewhere between a mole and a bat, I would like to look at a slightly bigger font, and it gives you, there we go, increase font size. That's nice, but once you've done that, make a liar out of me. It will sometimes not display the lines properly. It'll put gaps in and miss. Oh, we'll just see what happens. And also, the problem I was having with the web editor is the monitor. So it's the serial monitor, which has now opened on the other screen, and off we go. So that is just the test code which I've the board test code I wrote for the last video, which I've expanded a bit so I can use it to do the calibration. And I have done the calibration. So here it is. I've been calibrating it, and it's set up currently for current mode. So I've got the power supply running through the meter, running through a resistor, running down through the transistor in charge mode, and use that to calibrate the current. And I covered all this in a previous video, so I'm not going to go over it again. And two wires here, these are the current monitor wires, which I've disconnected and connected an extra wire in here just to calibrate the voltages, and I've done that, and again I covered that in a previous video. And I should have looked at that video myself, because I initially tried with the current monitor wires in, connecting the two ends of the battery together and connecting that to 12 volts, which shorts the 12 volts out, and I blew up the little 12 volt output on my power supply, which I sadly discovered didn't have any protection on it, and I had the first triplicate smoke, I believe, coming out of there, and sadly didn't have the camera on at the time, so I can't show you it. Okay, another thing I've done is got the FTDI based serial board, the little cheapo board, connected via, sadly, a grotty bit of Veriboard, but it works, and that's it. Connected it up and it worked. What more can I say? So if we look at the PCN, we then using standard serial functions, i.e. write file here, to drive the PC end. And if we go into the Arduino end, that's the read function, and we're doing just talking to serial port 2 and calling the read bytes function, which is a standard Arduino function for reading from the serial port. So very easy. And I have also abandoned my original idea of using a declared length and checksum message, because it's USB. It works or it doesn't. So I'm just using little messages which are text strings, which are actually the same format as being used for the file format. And I don't worry about a checksum, and I don't worry about getting confirmation they've arrived. I assumed they do. So if we now, what are we trying to do here? That's what we're trying to do. If we now run that, okay, there we go, we get our PC application, and here is our monitor. So if we load test BTR for battery, and there we go, it's just numbers I put in just to test it. And if we hit action and hit send, okay, you can see it here. This is just logging it the message is arriving, and that's just a list of what's in the task once it's arrived. So we can now send our settings down to the Arduino. So shall we see now if we can make it actually charge and discharge a battery? Okay. You would think I would know better, given my experience of doing this sort of things. First up, using a power wire that is basically white both sides, and yet the positive's got a black trace on it. However, how easy is that to connect the wrong way around? Well, I'll tell you, very easy. And you would think also, with my experience, I would protect the power supplies with diodes, just in case I do connect it up the wrong way around, which of course I didn't. So I ended up blowing up the relay drive transistor, which is on a very small footprint, 3 very small holes very close together, and it's through the hole plated, so you pull the old one out and you never get the solder out of the holes. So the new transistor is, let's see if we can get that in, so you can see we just tacked on the top of the board, so if I knock it I'll pull the pads off. Ho hum. However, and I have added some diodes. That's the charging voltage, that's the supply voltage of the diode in that tape. So having done that, I've repaired the board, and I've also written a lot of code, and we're ready to test it. To test it, I have built a sort of battery in inverted commas, which is this 20 odd ohm potentiometer, which goes across, what's the wire, a 12 volt supply, and then goes across the battery holder. So it allows me to charge and discharge and use this pot to control the voltage, rather than sitting here for 10 hours waiting for a battery to charge up. The only problem is this pot gets crazy hot. So you'll see me working with a pair of pliers and a screwdriver in a minute, and you can see it's looking burnt. So should we connect this up and try a test charge discharge cycle? Okay, so sorry about the neighbour's car alarm. Firstly, let us now fire up the PC editor. Run. Okay, here she goes, and also we will look at what the Arduino is doing, which is currently just saying it's currently just outputting the mode and the currents and voltages, which are none because it's all turned off. It's also sending these back to the PC, and they're being output here. Okay, so now let us load the test setup that I've created called debug. So this discharges 100 milliamps till it gets to 3 volts, and bearing in mind this is just for this test setup. So it then charges at 100 milliamps till it gets to 9 volts. It then goes into trickle charge for 2 hours, and I've speeded everything up, so that's actually 2 minutes, and then it just goes into monitor mode. Okay, so shall we send that to the Arduino? There we go, it's got it. And shall we fire it up and see what happens? Okay, so I will turn the 12 volts on the power supply, which is going to do the charging and run the relay. Right, this is the power supply for our battery in inverted commas, so I will turn this on now, and this little guy will start getting very seriously hot. And now if we look at the computer, yeah, it's showing 5.6 volts, and if we turn the meter on, it's not registered any volts. Okay, these little test leads are rubbish. The wire's very thin and it breaks off just in the connectors breaks, the conductors break just in the crocodile clip. Okay, so the red LED is a fault light if it's on all the time, and in standby mode if it's just blinking. So if we now go to the PC, we've sent our debug sequence down. So if we hit run, so it is now in discharge mode. The yellow LED indicates that, so if I were to grab that and reduce this voltage gradually, and we're looking at 3 volts to start charging. There we go, it started charging. The voltage has gone up a bit because these resistors are in series, and now it's putting voltage in. So far so good, it's charging. So now I increased the voltage, and it was 6 volts. Remember, it decides it's charged. No, 9 volts, sorry. Right, and it's now gone into trickle charge, so the charging light is just blinking to indicate it's in trickle charge, and after a couple of minutes or so that it will time out from trickle charging and go into monitor mode, where it's neither charging nor discharging, it's just keeping an eye on the battery voltage. And you notice the voltage dropped when it went into trickle charge mode, because now it's charging at a smaller current. Okay, keeping an eye on the timeout value here, so we're nearly there. Okay, and heard the relay click out, so it's in sort of nominally in discharge mode, but it's not discharging, it's just monitoring the voltage, and the yellow LED blinking indicates that. So it appears to be working. Okay, well I think I'm going to leave it there for this video. It's not been a long video, but I've done a lot of coding in the background because I just wanted to get on and get it up and running. So next time we can actually connect some batteries up and see how it performs, and investigate how rechargeable batteries behave a bit. It's going to be quite hard to make a video of, because of course discharging and charging a battery takes many hours. Anyway, we'll see. I'm sure I'll figure it out. So for now, that's it. Subscribe, comments, thumbs up would be nice, and I'll see you on the next one. And for now, it's goodbye from Triplicate, home of interesting electronics. Goodbye.